Assalamualaikum warahmatullahi wabarakatuh. I would like to say thank you for coming to my presenting. It's the great to see you all. Let me introduce myself. My name is Riana Mardliyah, and I'm from University Trisakti. In this opportunity, I would like to presenting a paper entitled "Effective Test of Using Natural Absorbent of Water Hyacinth Leaf in the Heavy Metal Lead Treatment in the Batik Industry Wastewater." Content include introduction, methodology, result methodology, and conclusion. First, introduction. The advancement of the industry has made many industry utilize heavy metal elements in their product, such as the metal plate making industry, the battery industry, the textile industry, and so on. Heavy metal pollution has become an environmental problem because it's accumulated in the food, harms ecosystem, and dangerous human health. Heavy metals are usually carcinogenic and toxic. Among the substances that are helpful to water, heavy metals are very helpful to organisms. The process of removing heavy metal uses various alternative methods, one of which is absorption. Absorption has been proved to excellent approach for heavy metal and semi-metal removal for wastewater and pollution soil. The absorbent used for the absorption process is relatively expensive, so that a cheaper and environmental friendly absorbent is needed. There are many natural absorbents that can be used and have a low cost, such as water hyacinth leaf, banana peel, mangosteen peel, mother-in-law plant flower, blood clamacil, and chicken egg shell that can be absorbent heavy metal. Preparing of absorbent. The first step in the manufacture of absorbent from the water hyacinth leaf can be taken from sphere or ponds. After the water hyacinth leaf have been cleaned, cut the water hyacinth leaf into the small pieces and dry in the sun for 3 until 5 days. After that, the water hyacinth leaf dry in the drying state. The water hyacinth leaf in the place in the porcelain dish and put the kiln at 3000 degrees Celsius for 25 until 30 minutes to produce charcoal. Water hyacinth leaves that have become a charcoal are decomposed and sieved using a mass sieve with the size of 100 mass. By soaking water hyacinth leaf in sulfur oxide solution for 24 hours with a ratio between 20% sulfur oxide solution and 2:1 ratio of water hyacinth leaf absorbent, the active carbon that has been left for 24 hours is then reset with the distilled water before being tried in the oven at 100 degrees Celsius for 2 hours. Preparation of stirred tank reactor. The stirred tank reactor is made of two parts, namely the drum and the string root, on the top of which the stirred machine that can be adjusted that spin is installed. The tool is made using plastic barrel with the height of 94 cm and the diameter of 4 cm, but referring to the design criteria in the pedal dimension, design was made with the higher height of 5.3 cm and the wall of 28 cm. From the tube in the plant that an outlet with the height of 25 cm for the discharge of the water after process is installed with a valve that can be open and closed. The tool will work in the batch system. Water will be collection first until the volume result 60 until 80 liters. Removal efficiency and analysis of absorption capacity. Lead removal efficiency. Equation 1 and 2 show the calculation of the removal efficiency and absorption capacity. Absorption isotherm. The interaction between two absorption pairs of the lead were also determined using the Lagmer and Fedorlik absorption isotherm model as illustrated by equation 3 and 4. Respectively, absorption kinetic, the percent of first and second order model were sought to discover the kinetic absorption behavior, which assumed that the ion is the absorbent at the single and the double surface location, respectively. The commercial comparisons for the kinetic model are started below equation 5 and 6. Result and discussion. Wastewater characterization. Samples were obtained from the batik industry. Wastewater in the batik dyeing process contain heavy metal. The content in the batik water option very highly 6.658 milligram liter. From the analysis, it was found that the water condition the high heavy metal with a lead as the water quickly standard according to the regulation of the Minister of the Environmental of the Republic of Indonesia number 5 of 2040. The permissible concentration of the lead is less than 1 milligram liter. Characteristics of water hyacinth leaf. Figure number 3 shows the water hyacinth leaf before activation, and figure number 4 shows the water hyacinth leaf after activation with 20% sulfur oxide. Effect of mass absorption and contact time. This study used a string speed of 200 RPM with the variation is contact time of 50, 13, 45, 60, 75, and 90 minutes with the variation in the mass of the absorbent 12.5, 100, and 500 grams. It can be seen that the absorbent mass of 12.5 gram with the contact time of 60 minutes has the higher presenting value of 98.30%. It can be calculated that the absorbent mass of 12.5 gram was chosen as the optimum mass for absorbing lead metal in the batik water. Absorption isotherm. The absorption of the lead by active carbon in the water hyacinth leaf is more likely to follow the Quadratic equation and than the Lechner equation. The result of the R rank 2 value from the Quadratic isotherm method is 0.9997, while the Lechner isotherm method has an R rank 2 value of 1. From the value of the R rank 2, it can be seen that the value of the Lechner isotherm proof is get the result of 1, which is a linear line. You have a C graphic of figure number 6 and figure number 7. Absorption kinetic. The correction coefficient integrated by the second order value with the mass of 100 gram, which has a higher value use of R rank 2 with the value of 1. You have C figure graphic in the figure number 8 and 9. Conclusion. In the conclusion, water hyacinth leaf have absorbent preparation that function as a metal binder, such as the lead optimal absorption at the absorbent mass speed of the 12.5 gram with the contact time of the 60 minutes at the speed of 200 RPM with the efficiency in the reduction heavy metal lead of the 98.30% with the final concentration of 0.1247 milligram liter. The isotherm kinetic of removing lead metal using active water hyacinth was followed by Lechner isotherm, will absorption kinetic follow second order. The quickly of the water produced after the absorption process using water hyacinth leaf meet the quickly standard required by the Minister of the Environmental. This is a reference. Thank you for your attention.